Alright guys, welcome to this set of videos, and what we're going to do here is this set of videos is going to follow along with the notes that come out of your textbook from Chapter 7, Section 3. And what we're going to begin to do, as I told you, Chapter 7 is going to be all about exponential and logarithmic functions, exponentials and logarithms. And now here in Section 3, we're going to get sort of our first introduction to those logarithmic functions. Now, why do we put exponential and logarithmic functions together? Well, I'm going to show you here in just a second how it works, but it turns out that logarithms and exponentials are inverse functions of one another, right? They're inverse functions, which means a couple of things. First of all, it means that if you put an exponential and a logarithmic function together as a composite function, they'll cancel each other out. So we'll go through and we'll show you how, we'll sort of explain to you how you get a logarithm from an exponential, why they're inverse functions. But that's why we've put exponentials and logarithms together here in Chapter 7. It's because they're inverse functions and they go together. Before we get started kind of jumping into this set of notes, let's get a couple of objectives or learning targets to kind of help us focus as we go through this set of notes. So here we go. I've got some objectives for you right here. Sorry, hold up. That was my highlighter. Right here I've got for you. The first thing that we're going to do is we're going to go ahead and take a look at evaluating logarithmic expressions. So this is going to be if I give you a logarithmic expression, can you evaluate it? Can you find me what that logarithmic expression is equal to? We'll almost always use our calculator for these, but you actually don't really need a calculator. There's other ways to do it, but I think most of you will probably be comfortable doing it with a calculator. And then we'll get to graphing. Of course, when here in Algebra 2, we have graphed in every single chapter. We've already looked at graphing exponentials. It makes perfect sense that we would graph logarithmic functions as well. And since exponentials and logarithmic functions are inverses, it would make sense that we would graph them together, since we actually did that a couple of chapters ago. Inverse functions, finding an inverse function and graphing them. Let's go ahead and get started by showing you why logarithms are the inverse function of an exponential. And I'm going to do that right here by giving you an exponential function. So I ask you to find the inverse of the exponential function, and I've given you f of x is equal to 2, the base 2, raised to the x power. Now this is an exponential function because the variable is in the exponent position, and of course my base is a 2. Now, if you remember from a couple of chapters ago when we did inverse functions, we can do it in 4 simple steps. And step 1 is to replace the f of x with a y. So that's step 1. Step 1, I just simply replace the f of x with a y. And the reason I replace f of x with a y is hopefully what you remember from inverse functions is that we switch the domain and range values, right? The x and the y have to switch places. So in step 2, the x and the y have switched places. Now, here's where our definition of logarithms come in. If you're sitting there thinking, I don't even know what a logarithm is, here you go. A logarithm is going to be that exponent. All right, that's what we call y. The variable y is called the logarithm of x. Very, very simple. Stick with me. I'll show you exactly how this works. I promise it'll make perfect sense. Here's what I've got. I want to know what power, right? What power do I have to raise this base to, right? I have a base of 2. What is the power that I need? What does this y have to be so that 2 to that power gets me x? And we call that a logarithm. When you're trying to figure out what that power needs to be, it's called a logarithm. You're trying to find the logarithm of x, finding that power. Let me show you. I'll do a couple of real quick example problems for you. I promise it'll make perfect sense. We actually looked at this in the previous section. What if I give you this? What if I give you 8 is equal to 2 to the x power? Here's what I'm asking you to do. I'm asking you to figure out what is the power that I need so that when 2 is raised to that power, it gets me an 8. Well, hang on, guys. I just told you right here, if you're solving for the variable, that variable, by definition, is what we call the logarithm. Guys, the y is the logarithm of x. We'll just take this and bring it right up here, right? And what I'm asking you to find is what power is needed so that 2 raised to that power is 8. Guys, I'm asking you to find the logarithm of 8. What does this power need to be? And here's how you're going to write it. The base of my exponential is 2. So I'm going to do a log base 2 because the base of my exponential is 2. I'm going to take a log base 2 of 8 because I want to know what power, right? What does this power need to be so that 2 raised to that power gets me 8. So I'm going to take a log base 2 of 8 because by definition that power is a logarithm of 8. So the log base 2 of 8 is equal to x. Well, guys, this one's really easy to do. Actually, you should already know this. 2 to what power gets you 8? Yeah, 3. 2 to the third power gets you 8. So guess what log base 2 of 8 is? Log base 2 of 8 is 3. So what you just did is you just solved a simple logarithm. You figured out what this power needs to be. It has to be a 3. And this power, by definition, is known as the logarithm, right? The variable y is called the logarithm of x. In our example problem, this x is the logarithm of 8. And to figure out that power, you'll just take the logarithm of 8 to figure out what that variable needs to be. Let me do another one with you. What if I give you 16 is equal to 2 to the x? Again, you need to figure out what power do I need to raise that base of 2 to, what does that power need to be to get me 16? Well, guys, you're taking a logarithm. You're trying to solve for the exponent, and this exponent is the logarithm, by definition, it's the logarithm of 16. So I will do a log base 2 of 16 is equal to x. Well, you don't need a calculator for this, guys. You know 2 to what power gets me 16? 2 to the fourth. So that means that if you were to use your calculator, which I'll show you how to do here in just a little bit, but if you were to use your calculator to take log base 2 of 16, your calculator is going to say, oh, that's 4. Yeah, because I need to raise 2 to the fourth power to get 16, all right? Logarithms are exponents, all right, guys? Logarithms are nothing more than exponents. All you're trying to do is figure out what that exponent needs to be to get you this value of x. And by definition, we call that a logarithm. So watch this. I am simply taking, right, I'm just trying to figure out what that exponent is by taking a logarithm. So we come back down here to our inverse. And here's what I've done. I have gotten to step 2 where I've switched the x and the y. And by definition, y is known as the logarithm of x. I'm trying to figure out what does that exponent need to be in order to get me this value of x. Well, up above in our 2 example problems, we said no big deal. In order to figure out what y is, all I need to do is take the logarithm base of 2, because that's the base of my exponential function. So I'm going to take the logarithm base 2 of x, and that'll get me y. Logarithm base 2 of x gets me y. All right, I just did the exact same thing we did right up here, right? I take the logarithm base 2, because that's the base of my exponential. Logarithm base 2 of 8 gets me that exponent. Guys, look at what we did right here. I have logarithm. I'm trying to figure out the x. So I'm going to take the logarithm base 2 of x, logarithm base 2 of x, gets me the variable, gets me y. All right? Now, I do want to point out real quickly this step right here, which I kind of skipped over to get down to here. Here's how this step works. And I want to make kind of a big deal of this because it's going to be real important later on. All right? What I've done is I've taken algebra says whatever you do to one side, you have to do to both sides, okay? So I've taken a logarithm because right, y is a logarithm by definition, that exponent's a logarithm. I've taken the logarithm of both sides. Please notice log base 2 of x. Algebra says whatever you do to one side, you have to do to both sides. So I've taken a log base 2 of x. I must also take a log base 2 of 2 to the y power, right? Algebra says whatever you do to one side, you have to do to both sides. For most of you, after I get done going through this example problem, almost all of you will skip this step because it's not really needed. You'll be like, oh, I know how this works, and you'll be able to skip over it. But I do want to show it to you right now because there's a really sort of important little part here that we're going to come back to later. And it's this. Whenever the base of the logarithm, which is a 2, and what you're taking the logarithm of, in this case, we'll call it the augment, all right? What is the augment of the logarithm, right? What am I taking the log of? Whenever the base and the augment of the logarithm are the same. Please notice it's a base 2 and I'm taking the logarithm of 2. Whenever those numbers are the same, they'll cancel each other out. The log base 2 and the base, oh, sorry, hold up, I apologize, that was my highlighter. Those guys will cancel each other out. It works actually exactly the same way. Just real quick here, over here on the side, quick example problem. Remember, when the index of the radical and the power were the same, like for example, if I were taking a 4th root of x to the 4th. Remember we said if the index and the power are the same, they'll cancel each other out and you'll be left with just an x. Guys, it's the exact same thing here with logarithms. If the base of the logarithm and what you're taking the logarithm of are the same, they'll cancel each other out and I'd be left with just the y. All right? Now, you guys almost always will skip this step because, again, it's not really needed, and you'll just kind of skip through that and go straight from here to here where you do the logarithm thing we did above. But I just wanted to show it to you because that's real important. I'll remind you of that later when we get on to some more advanced problems. But as long as the base and what you're taking the logarithm of are the same, they cancel each other out, and so that's why I'm left with just a y. Okay, we keep going. I have now solved for y, right? Because remember, step number 3 of finding an inverse function is once you've switched the x and the y, now you need to solve for y, and that's what I did. I got that y all by itself, and again, like I said, by definition, y was my exponent, and y is the logarithm of x, which is exactly what we now see. My exponent y is now equal to the log base 2 of x. That's why we call it a logarithm. You're trying to solve for that exponent, and that exponent by definition is called a logarithm. So y equals log base 2 of x. The last step, step number 4 in finding an inverse, is replace y with f negative 1 of x. Remember, this means inverse. So the inverse function, remember, I started with an exponential. F of x equals 2 to the x power. This is an exponential function. I go all the way through my 4 steps for finding an inverse, and I wind up with a logarithm. And the point here is simply this. I just spent all of that time to tell you this. Exponential and logarithmic functions are inverse functions. Exponential logarithmic functions are inverse functions, and that's why we've put them together here in Chapter 7. Exponentials and logarithms have been combined in Chapter 7 because they're inverse functions. So now what we're going to do is we'll go ahead and go through here in this set of notes. We'll go through just sort of rewriting. Actually, let me just jump back up to it. Your objectives, right? We'll evaluate logarithm expressions. We'll start there. I'll show you a real simple way to do it. Most of the time you use your calculator. And then we'll move on to graphing logarithmic functions. I'm really excited about this particular set of notes. I love doing logarithms. And hopefully for you guys, logarithms tend to be one of the more tricky topics in Algebra 2. A lot of kids struggle with it. I'm hoping that after watching these videos, you guys will just fly through logarithms. You may even enjoy them. I really like logarithms a lot. So head on over to the next page of the notes and we'll get started working with logarithms. I'll meet you guys over there.